on to question number 19. So ABC and DAB are similar isosceles triangle. So they are similar triangles and they are isosceles as well, where AB and BC, let's draw a simple triangle. So this is over A, B and C, where AB is equals to AC. So let's say this is isosceles triangle. AB is equals to AC. We have a bigger triangle as well. So we have D here and A and B here. The question says AD is equals to BD. So these two sides are equal as well because it's an isosceles triangle. And BC ratio, BC is 4 ratio and CD is 21. So this is 4, this is 21. So BD would be, what would be BD? So 4 plus 21, BD would be 25 parts because this is a ratio, that's not the value, okay? Now, if you're going to simplify, if you look at the scale factor, and we need to find out the ratio of AB and AD. So if you look at if you find the scale factor, how we normally find the length scale factor? Length scale factor, we're going to use the bigger one, AD, and we're going to compare this side. We're going to compare this side AD with the other side AD. Let's say AB is equals to this side AB is equals to this side BC. And do we know any value of this AD? We know AD and BD is same, so we can put over here 25 over AB, and AB we don't know, but we know BC is 4. If we do the cross multiplication quickly, so we left over here 25 times 4 is equals to AB squares. So we get over here 100 is equals to AB squares. If we take a square root on both sides, so we will get AB as 10. So we know that this length is 10 centimeter or 10 parts, okay? So what the question says, find the ratio of AB and AD. Let's write down here. So we have find the ratio of AB and AD. So we know that AB is 10 parts and AD is 25 parts. And if you divide both sides by 5, so you get a ratio of 2:5. So we got the ratio as 2:5. This is really good question actually. So but you just need to make two different shapes separately. Then you can figure it out easily using the similar shapes formulas and you get easily. Okay.